Solving this limit algebraically, and this is probably one of the simpler ones out of all the other examples. But how you would solve this is, first you factor this out, so factor, so then that would be limit x as x goes to 5, x minus 4 and x minus 2, because these equal to that, and you can have x minus 4 on the bottom. And then, as you can see, these would cancel out, so that would leave us with limit x to the 5 as x minus good. As the limit goes to 5, x minus 2, and then we just plug that in, so 5 minus 2 would equal 3, and that's how we solve it algebraically. Alright, so now we're going to be doing the conjugate form, and as you can see, if you just plug in 7 here, you get 0 over 0, and that's 7 plus 2 minus 3 all over 7 minus 7, which equals, 3 minus 3 over 7 minus 7, which just equals 0 over 0. So, since it's indeterminate, we can conjugate it and hopefully figure out what the limit is. So if we conjugate it, we get limit of x minus x as x goes to 7 of square root of x plus 2 minus 3 all over square root of x minus 7. We can find the conjugate of this because it has a square root. And the conjugate is just this with the opposite symbol. So times square root of x plus 2 plus 3 all over the same thing, because we have to multiply it by the same. Square root of x plus 2 plus 3. And then if we multiply these two, like this, the limit as x goes to 7, we can just find it out using, I forgot what the formula was, but like FOIL, for example, you get this, that's just x plus 2 minus 9, x plus 2 minus 9, and then you don't have to factor out the bottom because you'll see why soon. So x minus 7, x plus 2 plus 3, square root to x plus 2. And then as you can see, if we have this, since we didn't factor this out, it would be easier to just cancel out. So limit as x goes to 7, x minus 7, and then x minus 7 times square root of x plus 2 plus 3. And since we have that, we can just cancel out the 7s. So that equals to 1 over square root of x plus 2 plus 3. Plug that in, which equals 1 over square root of 7 plus 2 plus 3, which equals 1 over 3 plus 3, which equals 1 over 6. 1 over 6, and that's how you find the answer while conjugating. This equation, we're going to be using the L'Hopital's rule, limits with sign, and limits at 0. And if we just plug in 0 for x, we can see we get 0 over 0, since sign of 0 is just 0. And since that's an indeterminate form, we can try and use L'Hopital's rule to find out the limit. And by L'Hopital's rule, we have to find the derivative of this. So if we find the derivative of this, limit of 0, that is 2 cosine x minus 2 cosine 2x, right? Using chain rule, and then 1 minus cosine x. And if we plug that in, we get 2 minus 2 over 1 minus 1, which equals 0 over 0, which is the same as this, so it didn't change anything. And then let's try it again. we can do limit as x goes to 0, and that's -2 sine x plus 4 sine of 2x all over sine x. And since this is just sine x, sine of 0 is just 0, so we can just say this is also 0 over 0, which is the same thing as that. So we can do L'Hopital's rule again, and if we do it again, we get limit as x goes to 0, -2 cosine x plus 8 cosine of 2x all over cosine x. And if we solve for it, if we plug that in 0, we get -2 cosine. Cosine of 0 is just 1, so that's -2 plus 8 minus, or divided by 1, and that's just 6 over 1, which equals 6. And then we know that this is equals to this, which also equals to this, which also equals to this. So we know 6 is our final answer. So limit is at 6. Alright, so this example is limits at infinity. And for me, I find this the most challenging because it's kind of confusing. But I'm going to solve two problems with limits at infinity over here. And so basically what you can do with this problem is you can like divide it by x over 3. So we'll get equals. So basically limits at infinity and 5x all over x cubed plus 4 over x cubed all over 7x cubed over x cubed plus 2x over x cubed minus 1 over x cubed. And then if we simplify that, we get 5 over x squared plus 4 over x cubed all over 7 plus 2 over x squared minus 1 over x cubed. And because any constant divided by a variable when having limits at infinity equals 0, these all just cancel out. So this one's 0, 0, 0, 0, and that makes it equal to 0 over 7. And since 0 over 7 is just 0, the answer would be 0. And going on to the next problem, we can see since this is going to infinity, infinity plus 7 is still infinity, and infinity plus 6 is still infinity, infinity squared is still infinity, so that doesn't matter, so we can cancel out the 7 and 6. And then so we are left with 2x squared or 3x squared, and then you can just cancel out the x squareds. That leaves you with 2/3. So then 2/3 would be your final answer. Alright, so for the last and final part of my project, we're doing left and right hand limits. And so if we have f of x over here, which is -3x all over x minus 2, and we have a limit that goes to 2, f of x would not exist, because you can't have 2 minus 2 on the bottom, because that would just be all over 0. So in this case, we can do a left-handed limit and a right-handed limit. So a left-handed limit would look like this, which would be limit of x that goes to 2, that's left-handed. And since we have a left-handed limit, we can find a number that's infinitely close to the number 2, that's just smaller than 2. So for this example, let's do -3 and plug in x for 1.999999, and that's pretty close to 2. And if we do that same thing for the bottom, 1.999999 minus 2, we get negative over negative. And since negative over negative equals positive, we get positive infinity. So from the left side, it's approaching positive infinity. Now we can do the right hand limit. Limit as x approaches to from the right. We have to find a number that's infinitely close to 2 at, that's greater than 2. So we have negative 3, 2.0000001 as an example, and 2.0000001 minus 2, which equals, that's still a negative since you're multiplying, but the bottom goes into positive, which equals, since negative and positive are negative, we have negative infinity. So from the left, it's approaching the positive infinity, and from the right, it's approaching the negative infinity.